In this video, we're going to look at exponent laws, but for rational exponents. A rational number is any number that can be written as a fraction. So when we're talking about rational exponents, we're talking about fraction exponents. So to understand fraction exponents, we need to have a good understanding of roots. So when we think of a root, we might think of something that looks like this. We've seen this a lot. Something like that. What would we say this? What would we call this in English? We would say this is the square root of 16. But where are we getting the squared from? Well, every time we see a root like this, there's always been an invisible number, and it's been right there. Whenever we don't see any number beside the root sign, it's implied that this number is a 2. So we've called this square root. So how can you find the square root of 16? Well, we're looking for two numbers that when you multiply them together equals 16. So what two numbers multiply together to make 16? We know 4. 4 multiplied by itself twice makes 16. There's no plus or minus in front of here, so it's implied that we just need the positive answer. So the answer to the square root of 16 is 4. Let's apply the same idea to a different type of root. So this is called a cubed root. If there's nothing there, then it's a square root. But because there's a 3, it's a cubed root. That means that we're looking for 1, 2, 3. We're looking for the same number multiplied by itself 3 times. That makes 27. So what is that number? Well, 3. 3 multiplied by itself 3 times makes 27. 3 times 3 is 9, times 3 is 27. So the answer for the cubed root of 27 is going to be 3. Let's try another one. How about, what would this be called? This is called the fourth root. So we're looking for the fourth root of 625. So it means the same thing. Now we're going to look for one number multiplied by itself 4 times. Has to equal 625. So think about what that number could be. It has to be 5. 5 times 5 is 25, times 5 is 125, times 5 is 625. So that means that the fourth root of 625 is 5. And again, no plus or minus here. We're just going to take the positive one. I mentioned that because technically negative 5 times negative 5, 4 times would make 625. So unless we see that plus or minus there, we're just going to take the positive. Let's try another. Do you think you have this? Do you think you have a good understanding of this? If you do, try this one on your own. Just pause the video, come back just to check your answer. So if you're back, you're just checking your answer here. You should have been looking for a number multiplied by itself 5 times to make 32. That's what the fifth root means. And just from trial and error, you should be able to come up with 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So the answer you should have is positive 2. So now that we understand how roots work, I want to take a look at a different way that we can write roots. So we can write roots as fractions. So we're going to talk about how to convert a root from looking like this to looking like this. But let's make sure that this is actually equivalent to this. So your calculator, if you've got a scientific calculator, will calculate fractional or rational exponents for you. So into your calculator, put 27 to the power of, and then put this in brackets. Typically most calculators make us put this in brackets. 27 to the power of bracket 1 over 3, or 1 divided by 3, and bracket, and press equals. What do you get? Do you get 3? You should, because these two are equivalent. Can we start to come up with a pattern? I can see that the 3 is at the bottom of the fraction. Where does the 1 come from? Well, I don't see a 1 here. I don't see an exponent of 1. But remember that every number has an invisible exponent of 1. So that's actually where the 1 and the 3 come from. Let's try the next one and see if the pattern continues. Let's take a look at this guy here. So we know that the fourth root of 625 is 5. So here it is in exponent form. Let's first check to make sure that our calculator gets the same thing. Are these actually equivalent? So again, put right into the calculator 625 to the power of 1 over 4, 1 divided by 4. And what do you get? Check in the calculator, pause the video if you need to. All right, you should get 5. So is the pattern consistent with these two numbers here? So here our 3 was at the bottom of the fraction. Here our 4 should be at the bottom of the fraction. Yes. Where does the 1 come from? The invisible exponent that every number has. Very quickly, let's try for the last one. Okay, right into your calculator. Let's put 32 to the power of 1 over 5. If you put that in your calculator, guess what you get? You get 2, and the pattern's again the same. The 5 is at the bottom, so the root is at the bottom of the fraction, and our invisible exponent, it happens to be invisible this time, is right there. So every time we get a rational exponent, or an exponent that's a fraction, we're not going to freak out. It just means that our answer can be found by creating a root. So the pattern is that whatever number is at the bottom of the fraction, that becomes the power of the root. So it goes right here. And whatever's at the top of the fraction, that's the exponent that the base, the number underneath the root, is raised to. So the bottom goes outside the root. It tells you the power of the root. And the top number tells you the exponent of the base. So you can write this in two ways. No matter which way you write it, the bottom number of the exponent still tells you the power of the root, but this exponent up here, it can be applied to the number inside the square root, like inside, think of this like a bracket, inside the bracket, or it can be outside. It doesn't matter which way you write it. There's two ways. I show you both ways because one is usually more convenient than the other depending on the situation. So let's practice by writing this guy in two ways. We're going to write it this way and we're going to write it this way. So I'm going to start off with 4 to the power of 3 over 2. So we have, I'm going to write it out, 4 to the power of 3 over 2. And we're going to write it out this first way here. So the bottom number, b, always goes out here. It tells you the power of the root. So I'm going to put the 2 here. So this is a square root. And then the base is 4. So I'm going to put in here 4. And then this top guy, we're going to use this pattern. So I'm going to put this top exponent right inside right here. Okay, let's just follow to make sure. So the bottom goes here, top goes here, and let's simplify this guy. So you can consider roots like brackets. You got to do whatever's inside the bracket first. So 4 to the power of 3, that's 4 times 4 is 16 times another 4 is 64. So we're going to write 64. Okay. And then we're just left finding the square root of 64, and there's no plus or minus in front of it, so we know the answer is going to be 8. Let's rewrite it in another way. So I'm going to start off with 4 to the power of 3 over 2. And I'm going to start again by writing a root. I'm going to write the 4 underneath. And as per usual, the bottom number here goes outside the root. It goes here. Now the 3 here, we put it inside the square root the first time, but it can also go outside and we're going to get the same answer. That's what I'm trying to show you here. So we can also use this pattern here. So here we go. Let's deal with the brackets. The square root of 4 is just going to be 2. There's no plus or minus. And then I still have this cubed. So I'm going to put the cubed out here. Then we have 2 to the power of 3 is 2 times 2 times 2 is going to be 8. So it doesn't matter which way you do it, you're still going to get the same answer. Just one of the ways is usually more convenient than the other. So let's try a few examples where we're going to simplify and we're going to evaluate. So we're going to, if it works out to a nice number, we're going to evaluate. So as we go through this, if you feel like you've gotten the hang of it, just pause the video, do them on your own, and then come back just to fast forward and check through your answers. So let's rewrite this. 8 to the power of 1 over 3. I'm going to avoid putting it directly into my calculator. I can put it directly in my calculator if I just want to check. Let's make sure that we can simplify this from an understanding of what a rational exponent is. Okay, so we see a fractional exponent. We're not freaking out. We're going to start by writing a root. Okay, step number 1, the base. The base goes inside. So our base is 8. And then remember, this one's our B, our bottom. This guy's our A. The bottom goes out here. So this is the cubed root of 8. And then this exponent can go either inside or outside. It doesn't matter because it's just a 1. It's not going to change our answer anyways. So this just says the cubed root of 8. What number multiplied by itself 3 times is 8? It's positive 2. Let's keep going. Okay, here we go. We're looking for negative 81 to the power of a fourth. So we see a fraction. We're not freaking out. We're going to write it as a root. Here we go. What goes inside here? Is it 81? The exponent here is touching the bracket. That means everything inside the bracket goes underneath this square or this root sign. So I'm going to put all of negative 81 into here. And then, as per usual, the bottom of our fraction goes out here. So we have a 4. And then the 1, it doesn't really matter. It can go inside or outside. It's not going to change. So now I'm looking for one number multiplied by itself 4 times. 1, 2, 3, 4. That's going to make negative 81. Does that number exist? No, because if I choose a positive number, positive 3 for example, it's going to make positive 81. And if I choose a negative number, because I'm multiplying it by itself 4 times, it's also going to make negative 81. So there is no solution. No real solution to this. If you were to put into your calculator, you would get an error. Let's take a look at another situation that's similar to this one. What about this one? Does this one have an answer? Look how similar these two questions are. They're exactly the same except this one doesn't have brackets. So let's analyze this one. What does this mean? Well, first of all, I see a fraction as an exponent, so I know I'm going to rewrite this as a root. What is the base here? What is the exponent touching? In this case, it's just touching the 81. That means that that's the only thing that goes out here. And this negative is not invited to the exponent party, which means that it is not a part of the root at all. It's just hanging on outside here. Not invited to the party, just sort of outside. So let's now deal with the 4 and the 1. So the 4, we know it's going to go outside here, and the 1 is going to go here. So just take a look at these two, just to compare it one more time, just so that we really understand. Here, all of negative 81 was underneath our root. It was part of our base because that's what the exponent was touching. It was touching the bracket. So it's talking about everything in here. Here, the exponent is just talking about the 81. That's why we put it in there. And the negative's not invited. It's just sitting on the outside. So now can we solve this? Is there a number multiplied by itself 4 times and makes 81? Yes, it's going to be 3. So I'm going to copy the negative and then replace it with a 3. So in this case, the answer is going to be negative 3. Just a quick side note, just because you see a negative inside of a bracket doesn't mean that there's not going to be a solution if you're finding a root. We're so used to not being able to find a solution for the root of a negative number, but when we change the power, we might be able to find a solution. Here's what I mean. If I want you to find the third root of negative 27, so it would look like this. The 3 would go here and the 1. Is there such number that multiplied by itself 3 times makes negative 27? 1, 2, 3. Is there anything that would make negative 27? Well, let's try negative 3. Wouldn't negative 3 work here? Negative times a negative times a negative makes a negative. 3 times 3 times 3 makes 27. So we can, so this answer is going to be -3. Just because you see a negative inside, inside a root doesn't always mean there's not going to be a solution. It depends on what the power of the root is. So if it's odd, then we might be able to find a solution. If it's even, we will not be able to take the even root of a negative number. Let's keep going and working through these. So if you feel like you're confident now, you know how to do them, just pause the video, try them on your own, and just come back just to check your solution. So here we go. Inside of a root goes 16. We're going to put a 4 out here. Where should the 3 go? One option. I could put it inside here. If I put it inside here, do you know what 16 to the power of 3 is? Because I don't. I'd have to go to my calculator. So I'm lazy. I don't want to do the 3 here. Oops. I don't want to do the 3 here. I'm going to do it. Oh, why won't I erase? Come on, erase 3. There we go. I'm going to put the 3 out here instead, because we have a choice. So I'm going to calculate the 4th root of 16 first. That's going to be 2. Number multiplied by itself 4 times is, makes 16 is 2. You'll get faster at those, by the way. And now I'm going to do 2 to the power of 3, and I know that that's going to be 8. I would have got the same answer if I moved the 3, but now I don't have to touch my calculator at all, and it's so much faster. All right, last couple here. You should really be getting the hang of this now. Rewriting this as a root, we got 25. Out here should be a squared. Again with the 3, if I put it here, I don't know what 25 to the power of 3 is. I could figure it out, but why? I know what the square root of 25 is, so let's just put the 3 out here and make our lives easier. So we have the square root of 25 is going to be 5, and then we have all to the power of 3, and that's going to be 125. I don't care how you get 125, as long as you're showing your work all the way, it's perfectly fine. Our last example like this looks exactly the same. The only difference is that it has a negative exponent. So what does negative exponent mean? Negative exponent means that this base here is in the wrong place. So if it's at the top of the fraction currently, or if it's in the numerator currently, it belongs in the denominator. So it's going to end up being the exact same thing except in the denominator. So here's what I mean by that. First thing that I would do is, before dealing with it as a root, just move it. Move it down to the bottom, to the denominator of the fraction. And now let's go ahead and simplify it in the exact same way we just did. So we know what 25 power of 3 over 2, we can just rewrite it one more time. We've got a squared here, we're going to put a 3 here. And we already worked this out. This worked out to, was it 125? Yes. So it's exactly the same. Whoop, here we go. It's exactly the same, these two. Only difference is our final answer ended up at the bottom in the denominator. In these next few examples, let's go backwards. We're being given our answer as a root, and we're being asked to reverse and give it, rewrite it as an exponent instead. So here, think about this as our solution. What was the original question? So we know that as an exponent, the base would be 2. What number is outside of here? Well, if we don't see anything, it must be a square root. And what number is outside here? Again, if we don't see anything, it must be power of 1. So if I were to rewrite these numbers as an exponent, this would be 1 over 2. The 2 goes here, and the 1 goes there. How about this one? Let's rewrite this as a base with a power. So our base would be 36. What number is outside here? It would be a 1. So we can rewrite this as 1 over 3. And how about this last one? I'm going to make this a little bit harder. Let's put a negative in front of here. What would this look like? Well, what's our base? Our base is 11. We know this guy here, this 4 here would go at the bottom of the fraction. So it would be out of 4. And we know our top would be -3. So if we were to rewrite this, it'd be 1 over 11 to the power of 3 over 4. If you're wondering where did I come up with the negative, I just made it up right now just to make sure that we could deal with it if it was negative. So this last example has us to simplify first and then evaluate, which means in the end we should come up with a number, like a number solution. So let's go ahead and do this. What the heck would we do here? Well, I see a bunch of 8s with different powers or different roots. So this would be the square root of 8. This would be the third root of 8. This would be the sixth root of 8. What is the square root of 8? Is it a nice number? No, it's not. Square root of 8 is going to be 2 point something, almost 3. Is the cubed root of 8 going to be a pretty number? Yes, it's going to be 2. Is the sixth root of 8 a pretty number? No. So it would not be a good idea here to start converting these to decimals. What I do notice is that we have the same base over and over again. So what would we be doing if they weren't fractions? Well, we can just apply our exponent laws that we learned with integers. So for example, right here, isn't this a power raised to another power? What should we do with these two? We should multiply them. So these two we're going to multiply. So how do we multiply fractions? I'm going to do it on the side here. 1 over 6, and we're going to multiply it by 7. Multiplying fractions is super simple. We just multiply the top and multiply the bottom. So I'm going to put it over 1. So I'm going to multiply the top and multiply the bottom. So 7 times 1 is 7. 6 times 1 is 6. So that means the top can be written as 8 to the power of 7 over 6. So I'm going to use my exponent laws here because the sixth root of 8 is not a pretty number. It doesn't make sense to start using roots yet. Let's use our exponent laws. How about here? We have these two things of the same base and they're multiplying. What do I do with the exponent? What should I do with them? We should add them. Remember, we're going to add these two exponents. When the bases are multiplying, we can add the exponents. So how do we add fractions? We got to make sure that the denominators are the same. So the shortcut is I'm going to multiply this fraction here by this denominator. I'm going to multiply this guy here by this denominator. So I'm going to multiply this guy here times 3. So times 3 times 3. And I'm going to, 3. And then I'm going to multiply this guy here by 2. So I'm going to make it times 2 times 2. We need to make sure that the denominators are the same before we can add or subtract fractions. So this first fraction can be rewritten as 3 over 6 plus 2 over 6. I'm just multiplying what I had there. Okay, once the denominators are the same when we're adding or subtracting fractions, you leave the denominator alone and you add or subtract the numerator. In this case, we're adding, so it's going to be 3 plus 2 is 5. So when I multiply these two bases, we're going to add the exponents. And once I add the exponents, I get 8 to the power of 5 over 6. Okay, let's keep going with exponent laws. We've got division. What do I do with these two exponents? I have to subtract. So here I go, 7 over 6 minus 5 over 6. What does that work out to? Well, when we add or subtract fractions, the denominators have to be the same. And guess what? They are, which is perfect. So we don't have to do any more work. So I'm going to leave the denominator as 6 and then subtract the numerators. In this case, this time we were adding, here we're subtracting. So 7 minus 5 is going to be 2. I can simplify that. I can reduce it. Both the top and the bottom can be divided by 2. So this is going to work out to 1 over 3. So when I subtracted these two and we simplified, we got 8 to the power of 1 over 3. And now can we evaluate it? Is 8 to the power of 1 over 3 a nice number? Let's find out. So literally we cannot do any more exponent laws. It's just one base and one exponent. So all we can do now is just rewrite it as a root. So in the root goes 8. Outside the root, we know that this guy is going to go out here. And we know this guy is going to go either beside the 8 or outside. It's going to be the same thing. And we're looking for the third root of 8. And we know that's going to be 2. So we can combine our understanding of exponent laws, the power rule, product rule, all that stuff, and we can combine it with now our understanding of the connection between fraction exponents and roots.